Okay, the idea of the public subscribe from architecture is, think you have a newspaper. Give me a name of newspaper in Mexico City.
Reforma.
What's the name?
Of a newspaper?
Yes.
Yeah, Reforma.
Forma.
Reforma.
Reforma, okay. Is it? It's correct?
Yes.
Okay. In the Reforma, maybe you have a top like, for example, politics. Maybe you have city, you have sports, you have, I don't know, weather or forecast, okay? And others, okay? It's top. Things that you have, you want to know only about the politics. What you do? For example, you have a different guys that writing things about the politics. For example, this guy here only. I changed my picture a little. Give me a second. You have the Reformer, and you have a different topics. For example, you have sports. You have a second one that is politics. You have a order that is forecast, weather forecast. Okay? And you have different writers, okay? For example, these two writers write things to sport, okay? You have a different one that write things to politics, and other that write things to weathers, okay? Oh, sorry. Okay, this guy is the publisher, okay? And you have people that consume this information. For example, you have people here that read information from sport, okay? One guy signed registered to subscribe to politics and weather, okay? Okay, it is the publisher, okay? Sorry, subscriber. The topic is like it, okay? Think that you like a newspaper. Think that you have a different publisher. Which type of publisher? For example, you have a sensor that publishes information about your temperature. You have another sensor that publishes things about forecasts. You have another publisher that is a light that's publish its status, like turn on or turn off, or if it's smart light, can be the color, okay? You have, for example, another one that is like you, ultrasonic sensor that measure if the trash can's empty or full, okay? All of these devices publish a specific topic, okay? For example, one top for publish. For example, you can have a sensor that has multiple tops. Think so you have a device that has temperature and has, for example, humidity. Okay? These nodes or this device publish two topics. Or you have a more simplistic device that have only one sensor and publish only one information. Okay? And in the MQTT, you have a special entity that is the MQTT broker. What is the broker? The broker is like a newspaper, is the place where all the information flow, and it is responsible to organize and to provide the information to the subscriber. The subscriber can be a computer, a client, another application, okay? And you have the broker. The idea of the broker is very easy. Think that you have a sensor here, 3 sensors, and you have 2 subscribers, okay? To connect this the publisher to the subscriber, if you don't have broker, you need to make this type of connections. Okay. Which type of topology is this one? It is a star. Is it a star, guys?
Is it a what?
Is it a star?
I think yes, right?
Network topology. Is it a star? Okay, is it a mesh? Okay. Why is it a mesh? Why it is a mesh? Because all nodes connect with all nodes. It is complete. It is complete. As I said, is a complete, not economical. You need a lot of connection. To avoid the situation, you use a broker. Think the same situation here. You have 3 publisher and 2 subscriber, but you have a broker. In this case, you send the data to the broker, and the subscriber goes to the broker. It's more easy to organize. It's easier to organize. It's easier to share the information. Okay, guys. Only one advice: read and study the material that you already have. If you have questions about the previous topic that you use, I present, and that you already make some assignments, please ask, because you have a lot of things that you need to use this concept. For example, the network topology I present because it's important. Okay, the type of network, local area network, metropolitan, wide, is important to know. If you didn't know these things, you cannot finalize well this course, because you use this topic into write a report and to use inside our class. Okay. So again, MQTT use the public subscribe model, and you have a special entity, is the MQTT broker, that receives all the message from the publish and share this message with the subscriber. Okay. Remember that the subscriber need to sign or need to subscribe a specific topic. Things that you have in the broker, 3, 4, 5 different topics. You only what happens is every time that the publish one new information, the book redirects this information to the subscriber. And the idea to perform this task is something like that. Again, you have 2 different publish, okay? Publish A and publish B. A and B, okay? And you have a broker here, okay? And the broker, what's the publish? Okay, I put here, publish. What the publish does, the publish register thinks that this publish here has two topics. For example, on and off, and the second topic is a measure, a double measure, okay? Something like something that it measures in double. And this one has only one, okay? I don't know, a double, other double. I put names. This sensor here has a light. Oh gosh. Here is a light. Sensor, one off, is the values, okay? And a temperature, okay? That is a double, okay? Oh my gosh. And this one has only a light, okay? And what they need to do, the next step that they need to do, need to publish the things that it register the topics, okay? Now, the broker will have A light, A 10, and B light, okay? It's the topics that the broker has, okay? Things that appears a new one, the C, okay? And the C has one topic only, is door on, off, or close, open, okay? It needs to register your information to the broker, and the broker now has an additional topic, is C door. Any questions until here, guys?
No.
And the other guide that you have in these environments is the subscriber. The subscriber needs to register to, need to subscribe a specific topic. Think this one subscribe in the broker to receive this information. A light and B light. This one wants to receive a temperature and C door, okay? What happens is, for example, C published a new status of door. Now the door is off, okay? And send to the put name here, the broker, okay? Now C is off. What it means? It means that now C door equal off, okay? What the broker will do? The broker will send the information, oh my gosh, send the information to this device and C door equal off, okay? Now, lighting, A published, then the temperature equal 25 degrees, okay? The broker changed the state of light, the A light, equal 25, and sent information to the temperature to this node 2, and said, okay, light, A light equal 25. But think that B, now B published your state, okay? Light is off. You save this information key here and redirect to here and inform, okay, be light equal off. Okay, it's the way that the publish subscriber works. Any questions? No? Okay. So MQTT use a TCP and use publish subscribe model. Okay, it's a very useful because you simplify a lot the how the model is implemented. Okay, but the MQTT has additional features. For example, the MQTT has quality of service. What is quality of service? Quality of services is an agreement of level of service. For example, you can define, for example, what you do if you lost a package. You can define, for example, how many times you wait for receive the continuation of the communication to define that the communication is end. Okay, quality of service. Oh, sorry. Oh. Quality of service is a very important characteristic that network has to provide a very reliable networks. The MQTT provide persistence sessions. Okay, again, it's important because the MQTT use storing forward protocols. The last will, okay, the last will is a special package that one node send to inform that you leave off the network. Again, think in our example, you have one provider, okay, you have this case here. You have a publisher here, and that you have 2 or 3 subscribers that receive information from this publisher. The last will means, okay, when this, for example, the battery is close to finish, the publisher can send a last will message, inform to the broker that he will turn off in a few minutes or few seconds. And the broker send a message information to our subscriber. Okay, the application will know exactly when the node will leave to the network. It's the reason the last will and the quality of service is the reason that is very the MQTT works well in their rival networks. The next protocol is the advanced message queue protocol. It's close to the MQTT, use the public subscriber. However, the main characteristic is the queuing. This protocol creates queuing to store and forward, what improve the performance of the protocol and improve the scale of this protocol. The way is close to the first one. You have the publishers here, and you have the subscriber. What you have in the broker is a special model that create queues and use these queues to share the information to the subscriber. Why it's so important? Because you can implement these queues in different machines. You can have a cluster of brokers that provide service to you. In the MQTT, it's not possible. Okay, you need to, if you want to parallelize the process of MQTT, you need to implement outside the protocol. In the MQP, it's a feature inside the protocol. Okay, you can, for example, create a broker using 4, 5, 7 different machines, It's a real good because if one broker fail, you have order to assume the position of the first one. When you compare the protocols, MQTT, CoAP, and MQP, you can see the message model, and the CoAP is the different, is the request response. The other is the most modern, is publish subscribe. The CoAP use the UTP, the other one use the TCP, and compensate the TCP using quality of service. Okay, remember the TCP creates a lot of overhead of package inside your network, and if you use and decrease the performance, to compensate the loss of performance because you use TCP, you have the QoS. And because you use TCP, it's easiest to recover from a fail in the network. The CoAP and the MQTT does not use an encryption, so strong encryption model, and MQP use a very strong authentication secure layer. It's another important thing. The CoAP use only device-to-device model, and the MQTT use a device to cloud, and the MQP is a very advanced protocol. You can use a different type of model, use the protocol. It's a very scale, it's a very rich protocol. However, it's more hard to implement. So the implementation that you have that implement Edge, again, remember the first picture, you have the device here, you have the cloud here, and you have the Edge here. What happens is the Edge talks, for example, CoAP with device, MQTT with device, or other protocol. And it sends this message to the cloud, okay? It sends message, use this protocol to the cloud. But if the mode does not support, for example, MQTT, the Edge can translate to MQTT, enabling that this node talks with the cloud, okay? There are multiple types of implementation. I select 3 of them to show you. The first one is the Node-RED. We use Node-RED in this class today. We talk a lot of things about Node-RED. The second is the Azure IoT Edge. I'm preparing an extra exercise about the Azure, okay? To do the same things that you do today in the Node-RED. In the next week, you do the same thing, use the Azure. Why you don't use Azure in our project? You use Node-RED. The reason that all of the public clouds, for example, Azure, AWS, or the Google GCP, requires that to create the account, you need to pass or need to set a credit card. And I cannot obey you, force you. I cannot force you to have a credit card. It's the reason that you use different tools to implement these things. For example, you use Node-RED to implement the Edge instead to use the Green Gas or the Azure IoT Edge. Okay. However, I prepared an extra exercise that is not compulsory to perform to realize the exercise. Okay, I prepared an next exercise to be possible that you understand how to do these things in the cloud. Okay, but again, it's not a compulsory because I cannot force you to have a credit card. If you have a credit card and you want, you do this extra exercise. Okay, my idea is to publish on Monday. Again, so you have the Node-RED. Node-RED is not an Edge device, but you can create an Edge device using Node-RED. The Node-RED is like is an application that runs Node.js, okay? That is a JavaScript implementation of server, and you can create flows, okay? You can create this type of flows. okay? And this type of flows, you can implement a edge device using this type of flows, okay? It's what we're doing in the class today. For example, you have a different device, okay? You have a different device in your network using standard protocols or using legacy protocols, and you want to send this information to the cloud. You can install a Node-RED, and the Node-RED talks with the legacy protocols and transfer this legacy protocol to MQTT, for example, okay? Another model is the Azure IoT Edge. Azure IoT Edge, as the AWS or others, is very, very powerful edge. Okay, you have a lot of functionalities. Okay, and in my opinion, it is easiest to configure than the Node-RED and provide more service. Okay. The Azure IoT has two models. The first one is the at the runtime. That is the at runtime is responsible to is the core of the Azure IoT Edge. Is the core that is handling the information from the device and sends information to IoT Hub. And you have models, okay, where each model provides a specific service inside the edge. For example, you have a specific model that detects anomalies. You have other models that control the license and the patching of the device. Any question, guys?
No.
Okay, now we move. If you don't have questions, I will move to the second part of our class. In this part, we use Node-RED to install, to create an edge device. To perform this task, I need to do two things, okay? And I start to install the Node-RED now. And after the break, we start to create exercise using Node-RED. Just a moment, please. Okay. Okay, guys. Can you see my screen?
Mm-hmm.
Okay. Again, the first part of our lab is to install the Node.js, okay? Who didn't do yet this part? Who needs to install the Node.js yet? Who does need to install? Everybody installed? Yeah? Okay, perfect. So the next part is the installation of Node-RED. It's very simple. Node-RED install a package manager of nodes, okay, application. Node-RED is a Node.js application, okay? The Node-RED application, let me check if my pointer works. No. Okay. You apply this command here, okay? You open the Windows shell. If you are in the Windows, if you are in the Linux or Mac, you open a terminal shell, okay? And run this command here, okay? npm install -g -- unsafe pair Node-RED, okay? What npm will do? It will install all dependencies that Node-RED has and Node-RED, okay? please do this, perform this task now. While you perform, you publish the I will copy the comment and send the chat, okay? Give me a second. Okay, run this command, and after run this command, I will do the break, okay? Please run this command and we'll go through the break, okay, guys? I will give 10 minutes to perform this command. Oops. Oh, sorry. Okay, did you finalize it?
Yes.
Okay, guys. We'll give you a break now. Now it's 10:47. Yeah?
Yes.
Okay. You return at 11, okay? And after the break, we will do this exercise in the Node-RED. Okay, guys? See you soon. Any questions?
No.
Okay, perfect.